So here we're going to extend our knowledge of exponents and also fractional exponents to get a little bit more comfortable with simplifying expressions. So this should be very quick, but 2 squared is 4, 2 cubed, 8, 2 to the 4th, 16, 2 to the 5th is 32, 2 to the 6th is 64, 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81, 4 squared 16, this is 64, 4 to the 4th is, I think 256, 5 squared is 25, 5 cubed 125, 6 squared is 36, and 6 cubed is 216. So these are some numbers that we want to be pretty familiar with. Maybe there's a couple here that might be a bit of a stretch, but mostly we want to know those. Those are powers. Now, how about roots? 4 to the 1/2, 9 to the 1/2, 16 to the 1/2, 25 to the 1/2, 36 to the 1/2. These are just square roots. And in a sense, this exponent sort of makes sense because it's sort of like half of 9, but in a multiplication type of way. And almost like half of 16, but in a multiplication type of way. So it's sort of like, oh, what would have to multiply by itself to get 16? And 1/3 is sort of like a third of 64, but more in like a multiplication sort of way. I don't know if that makes sense to you or not, but this would be 2, this would be 3, this would be 4, this would be 5, this would be 6. Cubed root of 8, that's 2. Cubed root of 27, that's 3. Cubed root of 64, that's 4. Cubed root of 125 is 5. Cubed root of this is 6. Hopefully you see the pattern now. That's going to be 2, 2, 2. This is going to be 3. That's going to be 4. And you see how these two match up, right? Since 3 to the 4th is 81, 81 to the 1/4 is 3. Since 5 cubed is 125, 125 to the 1/3 is 5. So this isn't terribly challenging, but you do need to spend some time to sort of memorize this in a way. Compare your work from the 2 tables above. What can you conclude and recall about a to the 1/n? Write a sentence and mathematical equation. So we know that a to the 1/n power is the nth root of a. And so we could say a to the 1/n is the nth root of a. Whoopsie daisy. Sort of cut that off. Okay. Looking at this one here, it says rewrite the following using the power of a power rule. Okay, the power of a power rule says a to the m times n is equal to a to the m to the n. So that you have a fractional exponent raised to an integer power. So fractional exponent raised to an integer power. Then simplify the expression by evaluating the root before the exponent. No calculator. First problem has been completed for you as an example. So I'm not sure if you can see the colors here, but what this says is 27 to the 2/3. And that equals 27 to the 1/3 squared. So that's what I mean by having a fractional exponent raised to a power. But we know that 27 to the 1/3 is the cubed root of 27. And so the cubed root of 27 is 3, and 3 squared is 9. So this says 16 to the 3/2. So the first thing I want to do is write it as 16 to the 1/2 all cubed. Now 16 to the 1/2, that's the square root of 16 all cubed. And the square root of 16 is 4, and 4 cubed is 64. This says 256 to the 3/4, and that is 256 to the 1/4 all cubed, right? Because 3 times 1/4 is 3/4. But 256 to the 1/4 is the 4th root of 256, which we know to be 4. So that's equal to 4 cubed, which is 64. 64 to the 3/4 would be 64 to the 1/4 all cubed, and that is, I don't know. That's interesting, because that is asking us for the 4th root of 64, which I'm not sure I know what it is, and then that all cubed. Well, there might be some way to simplify this down a bit. fourth root of 64. Well, that's equal to the fourth root of 8 squared, right? Because 8 squared is 64. And that is equal to, well, fourth root of 8 squared is 8 to the 2/4 and then cubed. And that's 8 to the 1/2 all cubed, which is the square root of 8 all cubed. Oh my goodness. But the square root of 8 is the square root of 4 times the square root of 2 all cubed. And the square root of 4 is 2, so that's 2 root 2 all cubed. And that's 2 root 2 times 2 root 2 times 2 root 2. But 2 times 2 times 2 is 8, and square root 2 times square root 2 is 2. And there's a square root 2 there. So it looks like it ends up being 16 root 2. Oh my goodness. Wow, that's pretty challenging to get there. I think in general we might be okay just staying here. But this is definitely the simplest version. If you really want to be a mathematical queen, you can get all the way to 16 root 2. Wow, interesting. Okay, so number 5 says write out what the following mean in terms of roots and exponents, then simplify in your head. The first problem has been completed for you as an example. So 8 to the 2/3 is the cubed root of 8 squared, right? I know it's a cubed root because of this 3, and then I'm going to square it, which equals 4. So I'm not going to write this all out in the interest of the video not getting too long, but I will say it. 25 to the 3/2 is the square root of 25 cubed. The square root of 25 is 5. 5 cubed is 125. 81 to the 1/2 is the square root of 81, which is 9. Negative 27 to the 2/3 is the cubed root of negative 27 squared. The cubed root of negative 27 is negative 3. Negative 3 squared is positive 9. 16 to the 3/4 is the fourth root of 16 cubed. The fourth root of 16 is 2. 2 cubed is 8. 16 to the negative 3/2 is the same as 1 over 16 to the 3/2. So I'm going to make my exponent positive first. Now 16 to the 3/2 is the square root of 16 cubed. The square root of 16 is 4, and 4 cubed is 64. So this should be 1 over 64. So if it were just 16 to the 3/2, it would be 64, but because it's 16 to the negative 3/2, it should be division instead of multiplication, and that's 1 divided by 64. 6 I'm going to let you think about, right? Is this the fourth root of negative 16 squared, or is it negative 16 squared and then the fourth root, right? Is this thing real or not? Sort of an interesting thinking question to be figuring that out. Okay, looking at these graphs in number 7, the graphs of two power functions are shown below. The graph on the left is an odd power function, and the graph on the right is an even power function. We know that from the work we did in class. Given n is odd, so we're over here, and the equation y equals k, so y equals k, how many points of intersection occur if k is negative? 1. It's right there. Given n is odd and k is positive, how many points of intersection occur? Right there, 1. If it's even and it's negative, you're trying to cross the line k where k is negative, how many points of intersection? None. If n is even and the equation y equals k, how many points of intersection occur if k is positive? 2. So again, we're just trying to think about what these functions can be equal to. So coming down here, we can use our work to give the number of solutions to the following equation. So how many times does an even function cross a negative line? It doesn't, so there are none, no solutions, right? X squared does not equal negative 10. That doesn't make sense. You can't square something to get a negative. x squared equals 10. There are two solutions to this, plus or minus the square root of 10. X cubed equals negative 10. Well, there's one, because a cubic function or an odd power function will always cross both lines once. So it should be equal to negative 10 once, and it should be equal to 10 once. Coming back here, we get into some of the hard work. So it says solve for x without a calculator. Possible answer might be no real solutions. Hint 1, think about the equations graphically. Hint 2, you can undo an exponent by raising it to its reciprocal power. So x squared equals 64. Well, x squared looks like this. 64 looks like this. I should have two solutions, and they happen to be x equals 8 and x equals negative 8. X squared equals negative 64. Well, x squared does not cross negative 64, so there are no real solutions to this. It could be 8i and negative 8i if you want to bring in the imaginary numbers. X cubed equals negative 27. Well, a few ways to think about this. First of all, I could think about x cubed, which looks like this, and negative 27, which looks like this. They should cross once. I can think what cubed gives me negative 27, and that is negative 3. I could take a cubed root of both sides to get rid of the cubed root, and obviously that's going to give me negative 3. Or I could say, oh, I'm going to raise both sides to the reciprocal power, but that's the same thing because raising to the 1/3 and taking a cubed root is the same thing. So either way, it's going to get me negative 3. X to the negative 3 equals negative 27. I also think it's good to get a positive exponent here. So I'll write this as 1 over x cubed equals negative 27. So when you've got a fraction equals a fraction, you can just flip them both. So this is the same as saying x cubed equals 1 over negative 27. So now to get rid of this cubed, I need to take a cube root, or raise to the 1/3 power. And the cubed root of 1 over negative 27 is just negative 1/3. Okay, you can always check by saying, well, if I take negative 1/3 and raise it to the negative 3, will I get negative 27? Well, remember that a fraction to a negative power is the same as the reciprocal to the positive power. Sure enough, if I cube negative 3, I get negative 27 equals negative 27. So that should work out. Okay. X to the 1/3 equals negative 4. Well, to get rid of the 1/3, I can cube both sides. So raise to the reciprocal power. And that should give me x equals negative 64. Checking it. Negative 64 to the 1/3, is that negative 4? Yes, it is. X to the negative 1/3 equals negative 4. I could raise both sides to the negative 3. That will get rid of that. Just make it x equals negative 4 to the negative 3 is 1 over negative 4 cubed, because a negative exponent means divide. And that should give me x equals, well, negative 1/64. And because this is a cube root, an odd root, I should expect one solution, so that's good. X to the 1/2 equals 8. Well, square both sides, I should get x equals 64. Check my answer. Is 64 to the 1/2 8? Yes, it is. X to the negative 1/2 equals 8. Well, that's now the same as 1 over x to the 1/2 equals 8 over 1. So then x to the 1/2 equals 1/8. So I would need to find, I need to square both sides now. And I would get x equals 1 over 64. And that makes sense because basically this is just reciprocal equations. Finally, x to the 2/3 equals 16, so that means x equals 16 to the 3/2, because I can raise both sides to the 3/2 power. And this means the square root of 16 cubed, which is 4 cubed, which is 64. Certainly, the cubed root of 64 squared is 16. Now, the only tricky thing here is I took a square root, and when you take a square root of an equation, you should have absolute value. So it's really absolute value x equals 16 to the 3/2. And so that means that x should actually be plus 64 and x should also be negative 64. Reason being, if you take a cubed root of negative 64, you get negative 4, but when you square it, you get back to the positive 16. So anytime you've got that even power, you want to watch out for possibly having two answers. Finally, x to the negative 3/4 equals 27. I can raise both sides to the negative 4/3, and I get x equals 27 to the negative 4/3. So then x is equal to 1 over 27 to the 4/3. So x is equal to 1 over 3 to the 4th, which is equal to 1 over 81. And that takes care of it. So in general, you can raise to the reciprocal power, you can take roots, you can square things, cube things, but be especially careful if you raise thing to a something over 2 or something over 4. In other words, we're taking a square root here, or a fourth root, then you need an absolute value. You need the plus or minus solution. There's actually two solutions to this.